Hello everyone. So today we are going to learn about LSTM model for predicting a stock price. So this particular program is only for education purpose where you will know how to use an LSTM model to predict a particular underlying stock price or any kind of commodity or euro or any movement of that an underlying movement. This is not for trading purpose. This is only for education purpose only. So don't use this for trading. This is for only learning purpose. We are sharing this particular program and explaining you this. So what are we going to do in this particular program? Stock prediction using LSTM. Predicting the stock prices in the future is an important use case in finance. If we can build a model with reasonable accuracy, which can help us in predicting the movement of the stock price for an asset, it can yield excellent results. We'll use LSTM to predict the stock price for the security. So this involves, that is long short memory. This involves importing the library, downloading the data and checking it, data pre-processing, creating the training and the test data, defining the features and the labels, defining the LSTM model, model evaluation, and visualizing the predicted prices. Before you start, you should download the following: Yahoo Finance, Pandas, NumPy. So you have to pip install if you are running on your local machine, or if you are running on a Google Colab, that won't be required. For a mathematical operations, math, then matplot, lib.pyplot, RC prompts. Then for data normalization, min-max scalar from scikit-learn.preprocessing. For building the LSTM model, LSTM dropout dense from keras.layers. So first you have to import all these libraries: Yahoo Finance, Pandas, NumPy, matplotlib.pyplot, pylab, everything. Then after that, you can use the Bajaj Finance. In this example, we are used a Bajaj Finance sticker. You can use any of the stocks which you like, and we are given a period of 5 years. You can even give 10 years, 2 years, depending upon this. If you give more the period, it will be better for the model. Then we have used here df.head, which will give you the top data frames of this, whatever it has downloaded. Then df tail does the exact opposite. This is the shape of the data set. Then in this, we have plotted the adjusted close price of Bajaj Finance over the past 5 years. You can see this is the adjusted close price. Adjusted close price will take into account dividends and the close price at the end of the day, dividends, stock splits, or anything of that sort. That adjusted close price will take care. Then we are doing the data pre-processing. In this data pre-processing, we are making another data frame df1. This is the shape of the data frame df1. We are renaming the df1. You can go through this program, which is self-explanatory. You should do the following: reshape the prices array with the new shape as 1, 1, The new shape should be compatible to the original shape. If an integer, then it results will be a 1D array of that length. Our one shape dimension can be -1. In this case, the value is inferred from the length of the array in the remaining dimension. Normalize the data to the values between 0 and 1 using min-max scalar and save it as scaled prices. Remember that the feature range has to be passed as a tuple. So that is done here. Then creation of the training and the test data, which is very important. Usually we use 80% of the data as the training, which is used for training the model, and the remaining 20% we use it for the test data that we are defining here, 0.8. If you are using 70% of the training data, please use 0.7 and so on and so forth. But usually 80% and 20% is the normal procedure which is followed. This is the training length. Creating the training set with the first n rows of the scaled price, where n is the number of the records required in the training data set computed above. This is the training data. Then you have to define the features and the labels. We should input our data in the form of a 3D array to the LSTM model. First, we create a data in 60 time steps, before using the NumPy to convert into array. Finally, we convert the data into a 3D array with X training samples, 60 timestamps, and one feature at each step. we use the following step: create an empty list with the features X-train and the labels Y-train, create a 60-day window for historical prices as our feature X-train, and following the 60-day window as Y-train. Okay, so that is what is done here. Then this is your X test and Y test, and this is your X train and the Y train, which is in the form of an array. Then we have to define the LSTM model. How do you now you are ready to use the open source machine learning library TensorFlow to set up our LSTM network architecture. Define a sequential model which consists of a linear stack of layers. Add a LSTM layer by giving it 100 network units. Set the return sequence return sequence to true, so that the output of the layer will be another sequence of the same. Add another layer with 100 units, but we set the return sequence to false this time to only return the last output in the output sequence. Add a densely connected neural network with 25 network units, and at last add a densely connected layer that specifies the output. So that is what is done. Then from Keras model, import sequential. From Keras.layers, import LSTM. Then your model, add all these things now we are putting as a program. So this is the output of model sequential LSTM, LSTM1. This is the 60 step sizes which we have been talking about. Then training the LSTM model. So this will take time depending upon the speed of your hardware requirement of your machines. So depending upon your hardware, this program will take some time, usually 5 to 10 minutes it can take depending upon your hardware requirement. Finally comes to the model evaluation. Now you need to evaluate your trained LSTM model with the test data. Examine the performance of the model using root mean square error method. Here in the step, apply the model to predict the stock price based on the test using the predict method. Using the inverse transform method, denormalize the predicted stock price. Apply RMSE formula to calculate the degree of discrepancy between the predicted and the real price. So again, you have to run this code, then visualizing the predicted prices. So what you see in the green line, this is the this is the predicted prices, and this is the what the historical data. So from this you can predict the future prices using LSTM. Again, this is only for educational purpose. Don't take this as a trading indicator or something. You need to do lot of work and improve this model if you have to use it for the real trading purpose. I hope you like this video and this program which is available in the GitHub. Please do subscribe to our channel for more updates on this. We at OpenFin Innovation Labs, we run certification courses in data science, machine learning, and also on financial stock analytics, where we have a comprehensive course from fundamental of stock to the option trading to the advanced concept using Python. Thank you very much for your time.